In the previous video, we saw what types of relations would be functions. So just for a recap, a function would be those relations which are one-to-one or many-to-one, which means your output should be one always. So those types of relations are called functions, and the example for one-to-one was maybe it could be a straight line, or the best example would be a um, an exponential function, and many-to-one was usually we take a quadratic function for many to one, which is easy to understand. So a function, say I said a function where the inputs or x values is written as a function of x. So the notation is f of x. You can also change this letter. You can say g of x, you can say h of x, and so on. We can use any letter for this. And this x means that the input values are in terms of x. You can change that. You can say f of t as well. If you're talking about time, and if the equation is on a time basis, then you can also write that as f of t. For example, you know that there is a function in physics which is ut plus half at square. And this could be written as f of t because t is the variable. So the ones which are inside the brackets are variables, and these are the names given to the function f, g, and h, or anything. You can say anything here. So this is just a notation of a function f of something, g of something, and that something which is inside the bracket is the variable that's used in the function, which is actually from the domain. So I can say, for example, f of x is equal to x square plus 3, which means when x is equal to 1, I'm going to get the value as 1 square plus 3, which is 4. So how do I write this information? I write f of 1, because x is 1, is equal to 4. So when I substitute 1 into this equation, the whole equation becomes 4, which means f of x, which is 1 square plus 3, becomes 4. So f of 1 is equal to 4. So this is how we write a function when you're substituting the values. So you can substitute any value for x. Say I can substitute f of minus 2. So how will I find what is f of minus 2? I need to substitute it for x. So x is minus 2. Minus 2 square plus 3, which is 7. So f of minus 2 is equal to 7. So this is called substitution into the functions. So I can also substitute anything into the function. For example, I can substitute if I have f of x is equal to x square plus 2, I can substitute instead of x, I can substitute f of, say, t, and that should give me t square plus 2. So in the place of x, you replace it with 3t. So I can say f of, say, for example, f of x plus 1. So what should I do for that? I should put x plus 1 inside in the place where x was, and then I need to square this and add it with 2. So whatever I have here should be substituted in the place of x here. So if I have, say, for example, 2x plus 4, then your function would be f 2x plus 4 the whole square plus 2. So instead of substituting that just values like f of minus 2, in this case I'm substituting more functions into them. So this is called function inside another function. So f of g of x. So maybe g of x is 2x plus 4, and f of g of x is f of 2x plus 4. So for example, let's go for an example. F of x is equal to square root of x plus 1. Okay, and g of x is equal to, say, x square plus 2. And what is f of g of x? A function inside a function, which means I'm inputting g of x into f. So g of x is x square plus 2. So this x square plus 2 as a whole should be put into the place of x. So this becomes square root of, in the place of x, it's x square plus 2, and f of x is you add 1 to whatever x is. So the final answer for f of g of x would be x square plus 3. Okay, how do you do g of f of x? You can also do the same thing, which means you are inputting f of x into g of x. So f of x is square root of x plus 1, and g of x is g of x is x square plus 2. So you take f of x, which is this, and substitute into the place where you have x into this. So you should be writing x square for f of x, which is square root of x plus 1 the whole square, because f of x is square root of x plus 1, and for g of x you need to square that and add to this. So this is g of f of x. In short, we can write this as fg and gf. We also write this as f composition g. This is called composition of functions. So g composition f. So the small round here is called composition. This is an operation between two functions, which is called composition of functions. So you can plug in any function into the other, and you can see that there is a property coming up here. Fg, which was square root of x square plus 3, is not equal to gf, which is completely different. So in composition or is not commutative. F of g is not equal to g of f. Let's have some examples for composition of functions. So let's say there is an f of x function which is x plus 5, and there is g of x, another function which is square root of x. So we can actually plug in g of x into f of x and f of x into g of x. So g of x into f of x would be this one, and f of x into g of x would be this one. F of g of x, fog. It's not actually fog, but f composition g. The composition is a small round, it's not O. F of g of x would be f of x plus 5. Sorry, f of square root of x. G of x is square root of x. Therefore, f of g of x, f of square root of x. So when I say f of x is x plus 5, so if I have to put square root of x in the place of x, I will get square root of x plus 5. So this is f composition g. What is g composition f? We are plugging in g of x, f of x into g of x. So f of x is x plus 5, and this is supposed to be plugged into the value for x. So instead of x, we need to plug in x plus 5. And you can notice that even here, f of g is not equal to g of f. So that has to be kept in mind. Okay. Now, what are you doing for f of g of x? So if I have f of, let me write it like this, f of g of x. So if I have the domain of f, and if I have the range of f, so what I'm doing on f is I'm taking the g of x and I'm finding f on g of x, right? So this is how the map diagram would look like. So what I'm plugging in is not x, but it's g of x. Therefore, the domain of f should have the g of x, right? So what is g of x? If I make another diagram for g of x, what is g of x? This is g. So I take x here. When I have domain of g, which is x, and if I plug in x into g, I get g of x in the range of g, right? So we can see that these two sets are the same, right? So I can overlap the sets, and I can say you start with the domain of g, you start with an x value, do g on that, and then get g of x, and then do f on that, and then get f of g of x. So this is actually the map diagram for the composition of functions. You start with x from the domain of the g here, and then because you are plugging in g of x into f of x, you're doing the operation of g first. So find g of x, which means you'll get g of x, which is in the range of g. Therefore, the range of g and d of domain of f should be the same, or at least it should be subset of domain of f. So after getting g of x, you do f on that and you do f of g of x. So this is actually what's happening there. So if I make a clear diagram, domain of g, so you start with x and you do the operation on g and you get the range of g, which is you have g of x, and you have f here, and if you do f on this g of x, you'll get f of g of x. which would be the range of f, and this, because f is operating on g of x, this g of x should be in the domain of f. So range of G and domain of F play a very important role here. So in this case, the range of G should be a subset of domain of F. Otherwise, you cannot do that. If you have bigger set, then the F cannot be operated on G of X. So G of X should be contained in the domain of f. Therefore, g of x, the range of g should be inside the domain of f. So unless this happens, you cannot have composition of functions. So this is a general idea. So you need to find the range of f, the range of g, domain of f and domain of g, and then you know where it is. And when you can, you know whether the composition is possible by just looking at this condition. And another thing is, if you can see that f of x all the way started from the domain of G and went all the way to range of f. So for f of g of x, the x started from domain of G and came a long way to finally range of f. So for f of g of x, the x starts from domain of G and the overall answer goes to range of f, right? Which means the domain of f of g is actually equal to domain of G, and the range of f of g is actually range of f. So this is all about domain and range of composition of functions. So you need to have this condition and you need to know what is domain of the final output. So in if you want to find g of f of x, so you know that the first input value of x is into f. Therefore, the x comes from domain of f, right? And then you need to check whether domain of f is a subset of range of f, which is f of x, is a subset of domain of g, because g is going to be operated on f of x. Therefore, it has to be checked whether domain of f is a subset of range of f is a subset of domain of g. And the final output would be, which is the final output, g of f of x would be the range, and the range would be the range of g, because the final operation that you are doing is g. So the mapping diagram would look like this. You start with x, you do f first, so you go into the range of f, and then you see that the range of f is a subset of domain of g, and then you do g on that, and then you get g of f of x, which is going to be in the range of g. Hope this is clear.